Hello friends and welcome to this tutorial of Slidescope. In this particular tutorial we are going to discuss about some practical examples of supervised learning, and these practical examples will be dealt with some coding also, and the coding will be done in Python. So we have discussed that about the theory of supervised learning, the examples of supervised learning in our tutorials of machine learning, which are uploaded on Colors Tech channel of YouTube. In this particular tutorial, we are going to discuss the decision tree classification of supervised learning. So we discussed that supervised learning is of two types, classification and regression. So in case of classification, we have various algorithms like decision tree, support vector, and other algorithms are there. So we are discussing about decision tree classification. Decision tree classification or classification problems are used, or classification algorithms are used when the data is qualitative and not quantitative. So to first of all, to understand decision tree classification, where is decision tree classification applied, we have to understand what is decision tree. So a decision tree is a flowchart like tree structure where an internal node represents feature or attribute, the branch represents a decision rule, and each leaf node represents the outcome. So you can see here are possible outcomes: yes, no, yes, no. These are outcomes, and you can say this is a labeled output data, this is a classification data. The topmost node in decision tree is known as the root node. So in this example we are discussing about, or we have to make a decision about playing a game or not. So whenever the terms decision come, so or we have to decide, so in that case decision tree algorithms can be used. In this case there will be one, two, three or more inputs, and there will be more than one type of outputs. So for every type of input, for every possible combination of various inputs, the outcome may vary. So in this case, if humidity is high, then outlook can be sunny, overcast, and rainy. So if humidity is high and outlook is sunny, then the decision of playing is no. If the output is overcast or outlook is overcast, then the decision of playing is yes. If outlook is rainy, then also the decision is yes. So going with some data set where we have to decide whether we have to play or not, we are looking at certain conditions. So every condition leads to certain situations, and on the basis of those situations, the outcome may vary. Now when humidity is normal, uh, the condition is windy. If condition is windy, then the outcome is no. If the condition is not windy, then we will play, or then whatever whomsoever is deciding this thing will play. So there are three conditions where we will play, and there are two conditions where the person will not play. So this is example of decision tree. So in this particular chapter, decision tree classifier, we are going to discuss about a machine learning example on Titanic dataset. What is Titanic dataset? Titanic dataset is a very common dataset in the field of data analysis, and it is available for free on kaggle.com. And on kaggle.com you can find and download this dataset. It is in CSV format. This dataset is basically about the passengers of Titanic, and the passengers who were traveling in the Titanic ship when the accident took place. And this particular data set uh, explains about, or this particular data set tells the survival or unfortunate death of passengers. So this column here, which is labeled as survived, it tells that whether the passenger was able to survive the accident, whether he was rescued, or he or she was rescued or died. So if survived is 1, that means the passenger survived the accident, and when survived is 0, that means the passenger died uh, when that accident took place. These various columns here represent information about these passengers. So there's this passenger Braun, Mr. Owen Harris, uh, his sex, his age, what amount he paid for the ticket, in which class this passenger was traveling. So we have a separate video about Titanic dataset in which we performed exploratory data analysis on Titanic dataset. Exploratory data analysis is part of machine learning. In exploratory data analysis, we try to figure out the relationship between and output, various input data and output data. So in our uh, exploratory data analysis, we have uh, discussed about relationship between passenger class and output, relationship between gender and survival, relationship between relationship between age and survival. So in that exploratory data analysis video, the most number, the percentage of survival depends upon whether, if passenger was traveling in first class and passenger was female, then their chances of survival are most. Their chances of survival are more than 90% in case of if they were traveling in first class and if they were female. So you can watch that video to know some basic information about the Titanic dataset. If you have watched that video already, or if you have performed exploratory data analysis on Titanic dataset already, then you can watch this video to analyze the survival using machine learning's decision tree classifier algorithm. So first of all, we have to import common libraries like pandas. Pandas library is used to create data frames. Pandas library is used to read various data files like CSV files, Excel files, SQL files, HTML files. So any type of data, uh, pandas library can read that data. Uh, it saves that data in data frames. This data frame is a two-dimensional table-like structure. So this is a tabular way of representing data. So import pandas as PD. PD.read underscore CSV. This read underscore CSV method is used to read any particular CSV file. There's a method called read underscore SQL. There's a method called um, read underscore Excel. So there are methods to read different type of data files. So if you have a data file in Excel format, you can use read underscore Excel, and so on. We have discussed about pandas library. We have 4 videos where we have discussed about various methods and syntax of pandas that are useful for exploratory data analysis and machine learning. You can watch our pandas tutorial series, and that will give you good information, or that will give you good knowledge about the syntax of Python pandas. Df.head. This df.head is used to represent or is used to print top 5 rows of the data frame. So if you will simply print df, you will get all the rows. If you will print df.head, you will get top 5 rows. That's why we are getting top 5 rows. These top 5 rows are just to understand, are just to explore this data set, just enough to explore this data set. Here, P class, sex, age, and fare are numeric values which can affect the possible outcome. And based on our common sense and based on the information that we have from the exploratory data analysis, we can drop unwanted columns. So that's why in the line number 26 here, we are dropping passenger ID, name, SIBSP, patch, ticket, cabin, and embarked. So as per our analysis, these columns are not affecting in the survival of passenger. So that's why we can drop unwanted columns. Df.drop. So dot drop method is used to drop unwanted columns, and these columns are used as list here. So these are list of columns that we are dropping from our data set. Now after dropping these columns, when we once again when we look at our data set, so now you can see our data set has been updated and we have survived passenger class, sex, age and fare. Passenger class, sex, age and fare are input here, and survived is output. Survived is the value which we have to predict on the basis of various inputs. So this is the work of supervised learning. We discussed the definition of supervised learning, that in case of supervised learning we have labeled input and output data, and we have this sample data. We have to create our algorithm. We have to create our decision on the we have to create the function on the basis of the input and output data, so that we can predict future values. In future, these inputs will be provided to our machine, and our machine will be able to tell whether passenger survived or not. So although this data here is 0 and 1, it is a numeric data, but it is class. It is actually a class. It is actually a binary class. So you can call it yes and no also. So it does not mean numeric here. Here we have passenger class, where we have age and fare. These three columns are numeric, and this sex column here is not numeric. This is basically a classification, male and female. Again, this is a very famous example of classification. So let's move ahead. So the main task in decision tree classification problem is we drop the labeled output data from the main data set and save it as target, because this is the output that we have to predict in future, to be predicted for future inputs. And you have to save, you don't have to drop and let it drop, you just have to save that dropped column as a new variable. So this target here is a new variable which is nothing but this dropped column from the dataset. We are doing this to separate the input and output data. So from your dataset, the first step is to separate the input and output data. Inputs dot sex is equal to input dot sex map. This map function here will this map function here can be used to label encode the data. We can see here there are two genders, male and female, and we can encode these genders as 1 and 2. So it is helpful to label encode the non-numeric data in columns. Here we will have only two values. We are using a simple dictionary to label encode data. This is a dictionary. We have a separate video where we have demonstrated the use of label encoders. So in decision tree classification problems, we can also use label encoders. Here the labels are very straightforward, and there are only two labels, so we can manually encode them. But if you have more than one, more than two, three, four, you have five, six type of classifications in your data column, then you can use label encoders. So you can search for label encoders. It is very helpful in encoding your data because when you have to perform decision tree classification algorithm, when you have to use tree classification algorithm, it is important to encode the label, encode and the label the data. So we have a separate video on slidescope.com website where we have demonstrated the use of label encoders. That's a separate problem for decision tree classifier. Now, after labeling the data, we have to look if some data is missing in our data set. So if any particular column has some missing values, so in this case, the inputs.age.isNull.sum, this thing will predict how many missing values are there in case of age. And you can see inputs.age. If we'll look at top 10 age of, or if we will look age of top 10 passengers, uh, passenger between passengers who have ID of 0 to 9. So you can see that the passenger having ID of 5, he has a null value in age. So this data is not available. So there are around 177 inputs which don't have this data. Let's make this column to 40. Now you can see, so after actually we have performed a fill na method here, that's why we are getting that value. So you can perform or you can fill the missing values with mean of all values in the column age. So what we can do is we can fill the missing values with mean age or the average age. So let's say average age is, in our case the average age is 29.699. So every missing value is filled with 29.699. You can see 36, 32 here, 29.699, 31, 29.699 on 29, 20. So all the missing values that had null values in the data set, they are now replaced with 29.699, which is the mean age or the average age of age column. So this fill NA method is used to fill not available values, fill null values with whatever we want to fill it with. We can fill it with 0, we can fill it with 1, or we can fill it with the mean of age. Again, in our pandas tutorial series, in our pandas video tutorial series, we have discussed about fill na, drop na, interpolation, and various methods that are used to predict data, that are used not to predict data but to fill missing data, that are used to uh, fill the missing data with some value. We can fill the missing data with previous value, we can fill the missing data with upcoming value, we can fill the missing data using cubic functions, using quadratic functions. So there are various ways of filling the missing data, and that can be done after analyzing what type of data we have. So we have discussed about that also. So it is always good to have some basic knowledge of Python pandas. If you have some basic knowledge of Python pandas, then you will be able to understand these methods. Now this is our new input. Since we drop the output from this part and we save the output as target, so we have in case of input columns, we have passenger class, gender, age, and fare. So next thing is using the sklearn library. So we will use this library, or this sklearn library is very much useful for machine learning. It has all the algorithms of machine learning, and we are using this sklearn libraries to import train test split. So from sklearn.model selection, we are importing train test split model. So what it will do is it will split arrays or matrices into random train and test subsets. So your matrices will be splitted between train and test data. So there will be some training data, there will be some test data. So with the training data, we will train our model, we will train our machine, and with the help of test data, we will test various possible outcomes. So we will test the accuracy of our model with the help of test data. So this train test split method that we have imported here, it has um, it has two arguments. It has three arguments here. One is the inputs. That means all the this input here is the data frame. So this is the array of or matrices which we are going to train, test, and split. Then there is another argument called target. So our target argument is nothing but this survived column here. So this is our target or our, our argument. So you can call it as x and y. So and this is the test size. This argument here, test size, has a value of zero point 0.2. If complete value is 1, then zero point 0.2 means we are taking 20% of values from all values as test value. So this is the meaning of test size, that the testing data is 20%. Zero point 0.2 means 20%. Capital X train, capital X test, small y train, and small y test are the four variables in which these values will be stored respectively. Length of X train, that means how much data or how many rows of data is used to train the model. So 712 rows of data. So out of all the passengers we have used the data of 712 passengers. We have used these attributes of 712 passengers to train our model, and we have used the attributes of 179 passengers to test our model. Now from sklearn we have to import tree. So sklearn tree is a module that includes decision tree based models for classification and regression. So in this module, we have decision tree classifier, we have decision tree regressor, we have extra tree classifier, which is also known as extremely randomized tree classifier. We have extremely randomized tree regressor. We have export a decision tree in dot format, which is called exports graphviz. So we will discuss about these things in the later parts of our machine learning tutorial video. In this part, we are keeping things simple so that you can understand the. First of all, you have to understand the use of machine learning. You have to understand what is supervised learning. And when we tell the definition of supervised learning, as we have labeled input data and labeled output data, so we have to understand those things. So you can see here the gender is labeled as 1 and 2, which we did in the previous part. So this is labeled input and labeled output data. Labeled output data is the data of survival. uh, 0 and 1, this is binary labels here. Now the model that we are using from sklearn's tree module is decision tree classifier, because this is a problem of decision tree classifier. We will cover a separate problem where we will use decision tree regressor. When data is qualitative, when we have qualitative output in our supervised learning input data, we use decision tree classifier. When the data will be quantitative, then we will use regressor. So we will cover those problems also, and we will also uh, we will also upload a video where we will discuss about model selection. Means if you have to decide between various type of algorithms, where which algorithm will give most accurate results. So that will all be a video as well. But in this video, we are using decision tree classifier, and this is model.fit. So after creating the model, and after creating the model with decision tree classifier, this algorithm has all the mathematics to calculate all the values for us. And all we have to do is we have to use model.fit. So in decision tree classifier, we have a, a Gini criteria or Gini criteria, and minimum sample split is 2, minimum sample leaf is 1, and splitter is best. So these are this is the output that we have got from this command. So if we are getting this output, that means our the train x train and y train values are now fitted in the model. So now model knows about the training data. Now when the model knows information about the training data, then what we have to do is we have to test the accuracy also. We have to test the accuracy of test score. So what we did, suppose we had 100 inputs and 100 outputs. So out of those 100 inputs, we used 80 inputs to train our model, and 20 inputs to test. So that's what we are doing here. So now our model has the trained data. Now we are testing the data, testing the accuracy, how accurately will it be able to predict the output, and that accuracy is 78.77%. Now since we have got the accuracy score here, we can predict values. So model.fit, model.score, and model.predict, you have to remember these three methods. So from sklearn, import tree and create a model variable here. This model variable will be tree.decision tree classifier. This where sklearn tree is a module, right? And we are using decision tree classifier here because the we are dealing with qualitative data here. So that's why we are using decision tree classifier. And then there are only three methods to remember. Model.fit, model.fit has two attributes, x train and y train, that your training data. The model.score has two out again two attributes, the test data, and then the model.predict. Now here the number of attributes are in an array, you can see here. So this is a two-dimensional array here, and in this list you have 1, 2, 22, and 7.25. So the number of values here will depend upon the number of values that you have used for your inputs. So this, so whatever values you have used for your input, what you have to use it here. So one value can be 3, 1, 22, and 7.25. Another value can be 3, 2, 26, and 7.92. So these are the values. So we are predicting a passenger who was traveling in passenger class 1. And what is 2? The gender. The gender was female, and age of this passenger is 22, and the fare that this particular passenger paid was 7.2500. So This is giving us an array 1. That means this, according to our data set, according to the prediction, this passenger was able to survive. Let us predict another example here, and let's predict that one. What is one here? One is the passenger class. So let's say passenger was traveling in class 3. The passenger has a gender 1. Gender 1 is labeled for male. Age of passenger is, let's say, 25, and the ticket fare is, let's say, 7.2500. So let's keep the ticket as it is. And now you can see that our model is telling that, giving us an answer of 0. That means the possibility of survival of a male passenger of age 25 years traveling in third class, so it could not survive. So you can use these algorithms to predict the outcomes, and we have used certain exploratory data analysis techniques to predict the outcomes in one of our videos on Titanic Dataset. So the goal of this video was to demonstrate you the use of decision tree classifier when we have a certain amount of input and output, and we label encoded the data manually, and we splitted our complete data set into two parts, one with all the inputs and one with single output. And the single output is something which we have to predict, and when we are applying values, when we are applying the attributes of passenger, then our model is returning values in form of 0 and 1. We can, if it is we can give we can print more readable form of output also using if else, and that is a separate thing. So thanks for watching this video. If you have any doubts regarding this video, you can contact us in the contact us, or you can comment in the comment section of this video, or you can contact us on our website slidescope.com. Thanks for watching. Have a nice day.